Statistics, data processing in research projects. So you have a link here and you've got a YouTube link. So let's talk a little bit about the process of statistics. It makes use of sample data after the objectives have been stated to authenticate or falsify the hypothesis, so that the research question that was posed about the population in relation to a specific research topic can be empirically answered. Please pause a little bit and contemplate on that little phrase. So you must have a research topic, which is a study of the significant factors, for example, that influence the learning of mathematics. That could be a topic. Okay. Then you've got a research question. For example, is there a significant difference in mathematical abilities across gender? Do males perform better in maths or females perform better in maths? That could be a research question. A research question requires a hypothesis, a claim. So the researcher is claiming, well, there is no significant difference in mathematical abilities across gender. That's an example. So then you have the objectives. Specifically here is to determine if there is a significant difference in mathematical abilities across gender. And to do that now, here comes statistics, okay? Statistics deals with data collection, organization, presentation, analyzation to decide and conclude. So in this example now, the variable identified in this example is mathematical abilities. That is the variable. A claim was made in the line of males' performance or performing differently than females in mathematics. Now, please be aware of the fact that the claim is directed towards the entire population. So whenever you claim something, whenever you hypothesize, in fact, the research topic and the research question is about the population. Is there a significant difference in mathematical abilities across gender in the population? Now, however, statistics starts with the collection of data from only a sample in order to conclude or not with the claim. So yes, you're hypothesizing about the population, but you're going to use sample data to test that hypothesis. So please note and please be aware of the difference between population and sample. So now you have what you call the hypothesis. You have the null hypothesis and the alternative hypothesis. They come in pairs. It's like two persons debating. So to see who has won the debate, you need statistics. You have to collect data. Collect data is like gathering or obtaining the data using a sampling technique and a questionnaire. Collect the data. Now, when you collect the data now, it is raw. When you look at the raw data, you're going to have tremendous difficulty in going back to the hypothesis to see if it is true, because you cannot really deduce information from raw data. It's very difficult. So you have to go a step further and do something with that data. You have to organize the data. Present the data using tables to make it presentable. Now, if you notice now, I noticed that this morning. Do you notice that presentable is like a composite word? Present and table. Never noticed that? Presenting data in tables, yes? To make it presentable, isn't that so? Now, when you make it presentable, you're still going to have difficulties to verify the hypothesis, because you're going to have a table with a bunch of numbers, yes? So you have to continue processing the data. What are you going to do with it? You're going to represent it. Representation. You're going to present the data again. You're going to represent it using diagram. Now, when you do that now, when you create the diagram and you look at the diagram, you may deduce information from it and may be able to go back to the hypothesis to verify. We have done that in worksheet A. But sometimes, to be certain, to be very objective, because when you visually look at data, when you visually look at a picture, there might be some subjectivity because different persons might see something different, isn't that so? Multiple persons looking at a picture and they might have different perspectives, isn't that so? So the diagram might not be convincing enough. It might not be objective enough. So you have to go a step further, which is analyzation, agreed? The calculation of numerical values, the calculation of numbers, that is being very objective. And these numbers are called descriptive measures that can be statistics if they were calculated from a sample, or parameters if they were calculated from a population. So once those numerical values or descriptive measures have been calculated, that is being very much objective because they come from formulas. Formulas are unbiased. Formulas have no emotion. Formulas are very much objective. Everyone supposed to get the same answer using the formula properly, isn't that so? Unlike viewing the diagram, someone might say no, someone might say yes, someone might say approximately. You have that variability, you have that biasness when viewing diagrams, but when calculating numbers using formulas, there is no left or right. And now you're in a position now to decide what? Either you reject or you do not reject the null hypothesis. That's how it is established. And then you can empirically conclude with the null hypothesis if it was not rejected, or conclude with the alternative hypothesis if the null was rejected.